Good day everyone, I am your teacher Jessa, and for today's video we are going to discuss about the applications of derivatives of functions. So we have here a set of problems, but first let's just focus on the number one problem. So consider the graph y is equal to s of t representing the position in kilometers of a delivery truck from a warehouse. Time t is measured in hours after 8 a.m. So the first question goes like, when is the truck closest to the warehouse? The exact answer cannot be actually determined because the graph is not shown in the image or in the given in the given problem. So in letter B, describe the motion of the truck from 8 a.m. to 2 p.m. And the same in A, it cannot be described since there is lacking in graph. And also in letter C, the C asks the if s prime of t is equal to 0, what does this indicate about the truck's motion? If s prime of t is equal to 0, it means the truck's velocity is 0. This indicates that the truck is temporarily stopped or changing direction. Now let's go to letter D. What does s prime t represent? What about the second derivative of s of t? So s the s prime t represents the velocity of the truck, and then the second derivative of s of t represents the acceleration of the truck. So now let's proceed to number 2. So we have here for a while. Sure. So number 2 question. A cup of coffee is placed on a table in a room with constant temperature of 25 degrees Celsius. Let T prime T be the temperature of the coffee in degrees Celsius after T minutes. So in letter A, what does T of 10 is equal to 60 mean? So as you can see, it means that after 10 minutes, the coffee's temperature is 60 degrees Celsius. Next is letter B. Suppose t prime 10 is equal to negative 1.5. What are the units of t prime t? What does this value mean? So the units of t prime of t are degrees Celsius per minute. So the value of t prime of 10 is equal to negative 1.5, means that after 10 minutes, the coffee's temperature is decreasing at a rate of 1.5 degrees Celsius per minute. So let's move on to letter C. Estimate the T of 12. So using linear approximation, we can say that T of 12 is equivalent to T of 10 plus T prime 10 multiplied by the quantity of 12 minus 10. So we substitute the given or the value. So t t of 12 is equal to 60 plus negative 1.5 times 2. So t of 12, if we're gonna solve it, it will be 60 minus 3, and then our t of 12 is equal to 57 degrees Celsius. So therefore our t of 12 is equal to 57 degrees Celsius. So number 3, we have this problem. A ball is thrown straight upward from the ground with an initial velocity of 64 feet per second. Its height after t seconds is given by this is our equation as of t is equal to negative 16t squared plus 64t. So our A, find the velocity and acceleration function. So our velocity is v of t is equal to s prime of t, that would be negative 32t plus 64. And our acceleration is a of t is equal to v prime t is equal to negative 32. So, moving on, we have our letter B. When does the ball reach its maximum height? The ball reaches maximum height when the velocity equals 0. So, what we're gonna do is our equation in the velocity, we should equate it by 0. So, we have now the equation of negative 32t plus 64 is equal to 0. So that would be 32t is equal to 64, and then we divide both sides by 32, so the answer would be t is equal to 2. So therefore, the ball reaches its maximum height after 2 seconds. So now, our letter C, what is the maximum height reached? So we should evaluate S of 2. So that would be S of 2. Um, this this original formula was came from our original equation. So we're just gonna input the 2. So that would be negative 16 times 2 squared plus 64 times 2. And to solve, we will attain negative 16 times 4 plus 28. So our S of 2 is equal to 64. That's why, therefore, the maximum height is 64 feet. And our letter D, when does the ball hit the ground? So we should set our S of t into 0, equate it again from our equation, negative 16t squared plus 64t is equal to 0. And then if we are going to solve this, we can attain t is equal to 0 or t is equal to 4. But since t is equal to 0, that is our starting time, then the ball hits the ground after 4 seconds. So, to proceed, number 4, our problem goes, a company manufactures headphones and the cost function is given by our equation c of x is equal to 0.02x squared plus 30x plus 500. So, our A, find the average cost per unit. So, our average cost function, the formula that we use is A of x is equal to c of x over x. So, so we were just gonna substitute using this formula. So our c of x, that is 0.02x squared plus 30x plus 500 over x. So that's why our average cost function is A of x is equal to 0.02x plus 30 plus 500 over x. So next problem is find the marginal cost c prime of x. So we should differentiate the cost function. So that would be, our original function is c of x is equal to 0.02x squared plus 30x plus 500. Again, this function came from our original problem, and then we're just going to differentiate it to get the marginal cost. So that would be if we gonna perform this, we can attain c prime of x is equal to 0.04x plus 30, because this one will become 30, and then 500 will become 0 from the constant rule. So our letter C, compute the average and the marginal cost when x is equal to 500. Again, our average cost, we're just gonna input 500 to solve this problem. So that would be A, input 500, that would be equal to 0.02, and input 500 again, plus 30 plus 500 over 500. If you are wondering where did we get this formula, it is from this average cost formula here. Because that will be that is what we are going to use it to compute the average cost. So again, if we gonna perform these operations, then we can get A of 500 is equal to 41. So that is our average cost, 41, if our x is 500. Next is the marginal cost. So that would be C prime of 500 is equal to 0.04 times 500 plus 30. That would be C prime of 500 is equal to 50. So our marginal cost at x is equal to 500 is 50. Again, this formula was taken from here, the marginal cost. We just need to input the 500. Alright, so letter D, interpret the meaning of marginal cost at x is equal to 500. So our answer would be the marginal cost of 50 means that when 500 headphones are produced, the cost of producing one additional headphone is approximately 50 pesos. So to proceed, our number 5, the population of a small town is modeled by P of t is equal to 2,000 plus 150t, where t is measured in years. So our letter A, what does P of 5 represent? So P of 5, we're gonna solve this by P of 5 is equal to 2,000 plus 150 times 5. That would be our P of 5, that would be 2,750. So we can see, or it also it actually foreshadowed that our P of 5 represents the population after 5 years, which is the 2,750. Okay, so our letter B, find P prime t and interpret its meaning. So first, we need to differentiate the functions. The original function, which is P of t is equal to 2,000 plus 150t. So our P prime t is equal to 150 because this to derive this 2,000 will turn into 0 and this 150t will turn into 150. So that's why our answer is 150. So our interpretation for that is the population increases at a constant rate of 150 people per year. So letter C, is the population increasing or decreasing? How do you know? So the population is increasing because P prime t is equal to 150 greater than 0. So it is a positive, and a positive derivative means the function is increasing. That's why our population is increasing because of this one. So letter D, what does the constant rate of change tell you about the model? So it tells us that the population grows steadily by the same amount every year by 150 people each year. Alright, so down to the last problem. So we have the problem number 6. The distance traveled by a cyclist is given by S of t is equal to t cubed minus 60 squared plus 90, where t is in hours and S of t is in kilometers. So I want you to take note of this equation because this equations plays an important role for us to be able to solve for the given problem. So our A, find the velocity and acceleration functions. So again, velocity is the first derivative. So our original function, as what I said, we have to take note of that. S of t is equal to t cubed minus 60 squared plus 90. So that would be our velocity of t is equal to s prime of t. So v of t is equal to 3t squared minus 12t plus 9. That is our velocity functions. And our acceleration, to get the acceleration, that is actually the derivative of our velocity. So we have to use this one. At is equal to v prime of t. So that would be, if we're gonna derive this, we can get 60 minus 12. So that is our acceleration function. Alright, We have B. When is the cyclist at rest? So the cyclist is at rest when velocity equals to 0. So our original function, we need to equate that, we need to equate 0. So, and we notice that 3, 12, and 9 have a common, is factorable, can be divided by 3 rather. So let's divide that by 3 to make the function, simplified version. So that would become t squared minus 4t plus 3 is equal to 0. And then notice that, to factor, if we're gonna factor it, we can get t minus 1, the quantity of t minus 1 times the quantity of t minus 3 is equal to 0. So our t is equal to 1 or t is equal to 3. So the interpretation is that the cyclist is at rest at t is equal to 1 hour and t is equal to 3 hours. So letter C, this is quite a lot. Yes. So this is really quite a lot, no? Because there's a lot of interpretation when it comes to this. So let's read letter C. When is the cyclist speeding up? So a cyclist speeds up when velocity and acceleration have the same sign. Okay, I want you to take note of that. It will just speeds up if the velocity and acceleration have the same sign. So it feels like, it feels like the when you notice the multiplication in integers, so that would be it. If the same sign, then positive. So that's when a cyclist, accelerate or speed up. So notice our velocity is v of t is equal to 3 times the quantity of t minus 1 multiplied by the quantity of t minus 3, and our acceleration is e of t is equal to 6 times the quantity of t minus 2. So we have to check the intervals so that we can able to imagine or to show if it speeds up or not. So in the interval of 0 is, t is greater than 0 and less than 1, our velocity is positive and our acceleration is negative. So since it's different sign, then we can say that it does not speed up. So for the interval of is greater than t is greater than 1 but less than 2, so our velocity is negative and our acceleration is negative. So since it's the same sign, then it is, yes, it's speed up. So for our interval t is greater than 2 but t is less than 3, so our velocity is negative and our acceleration is positive, then the answer is no, it does not speed up. Then in the interval of t is greater than 3, then our velocity is positive and our acceleration is positive, then it does speed up. So what can we say, or what is the interpretation of this? So therefore, the cyclist is speeding up on t is greater than 1 but less than 2, and t is greater than 3. All right, I hope that you can get from that overwhelming answers there, right? So for the last one, we have the letter D. So describe the motion of the cyclist from t is equal to 0 to t is equal to 4. All right, so first is from t is greater than 0 but less than 1, the velocity is positive, so the cyclist moves forward. At t is equal to 1, the cyclist stops. From t is greater than 1 but less than 3, the velocity is negative, so the cyclist moves backward. And at t is equal to 3, the cyclist stops again. But from t is greater than 3 but less than 4, the velocity is positive, so the cyclist moves forward again. So what can we get from that? What is our interpretation for that? So therefore, the cyclist moves forward, stops at t is equal to 1, moves backward, and then stops at t is equal to 3, then moves forward again. So that's all, students. Thank you so much for listening, And I hope that you've learned a lot from our set of a given set of problems involving the applications of the derivatives of functions. So thank you so much once again. I am Jessamine Sparsha.